Now, we did something to a power, but we could also...
Do something with the roots.
Yes, so the nth root of a complex number. This top part is talking about nth roots of unity. That has to do with if z equals 1, which is a unit, right?
Complex number z, right?
Yes, complex number z is 1, which means it's really 1 plus 0i.
Right.
Remember, that's a complex number. We'll have some problems where we have to find the nth, like the fifth roots of unity or whatever. And so they're talking about finding like the fifth root of this complex number.
Right. What times what times what times what times what is 1. And we've told you all these years the square root of 1 is 1. Well, maybe we lied.
Maybe. I hope not.
Me too,
That'd be
because
awkward.
lying's bad. It's in the 10 Commandments.
Yeah. So we'll do that in a second. Just in general, though, finding nth roots of a general complex number. If this is our complex number in trig form, we use this formula right here, which is a little bit on the complicated side.
But we're going to assign almost all of those variables value, and once we substitute in those values, we'll be off and running, and then it cleans itself up quite nicely.
Yes,
actually.
Yes, it does. Keep in mind we're finding the nth root, which means that we'll know what n is. Like if we're finding the cubed root, then n is 3. That's this problem, example 7 we're about to do. So n is 3. Okay, because we're trying to find the
By the way, if
root.
you're at the bottom of your page when you do this, you may need to find some fresh space, because these can
well, I left space,
grow
but
exponentially.
somewhere in this general area, there is a page turn that you want to make sure and turn the page.
Right, okay, all right.
You know, that kind of thing. So n equals 3.
Okay, so n equals 3.
The other thing in this, besides r, well, we could say what r is. R is 3 as well.
R is 3 because it's the number in front, and then theta is there you go. Theta is 4 pi over 3. Okay, now k is going to be 3 different things, but it's not going to be 1, 2, 3. With k, you actually have to start with 0.
Yeah, that's what this part right here is saying. We start with 0.
And we go up to n minus 1. Well,
if n is 3,
n is 3, then 3 minus 1 is 2.
And so one way that will help you out is if we're finding the cube roots of it,
you should have
3
Ks.
things. Okay, because there are 3 different things that end up being the cube root of the complex number.
Right.
Okay, so we plug into this formula right here.
Plug it in.
The third
root of 3. Now, while Mrs. Stevenson's writing all this stuff down and plugging we now know what all our variables are, so she's going to fill in all of this stuff. Right there in the front where it says the cube root of 3, please do not write a decimal. That is going to be incorrect, okay? This is a situation where we want an exact answer only. The formula they give us is the nth root of r. They don't give us an equivalent approximation, blah, 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 whatever. So we just leave it as the cube root of 3, and there isn't one that we know of right off the bat that's pretty, so we just leave it that way, okay? Then very, very, very carefully fill in the rest of your stuff. Now, right here, k should be 0 since this is our first.
Well, I was going to do a little what if kind of situation.
Oh,
what if we
some
simplify? Here's something I like to do. I like to go ahead and simplify this where it's k, and then it'll be easier to plug in 0, 1, and 2.
Whatever you want to do,
If right now
Steve.
we plug in 0, 1, and 2, 0 will be pretty easy, but 1 and 2 require common denominators. If we just go ahead and simplify it right off the bat, then we'll only have to do that
Let's
math
do it.
once.
Let's do it.
So
Let's simplify. I like to simplify. It's
come up
good for
here.
me and builds character.
4 pi over 3 plus, now we want a common denominator of 3. So 2 pi over k right now, it has a denominator of 1. We want it to be 3, so we times the top and the bottom by 3 and get 6 pi k.
So this is exactly like adding the fractions up from when you were a child, except these fractions are quite nasty.
Well, yeah.
I mean, but the process is the same.
So they have a common denominator, so we put them together on top. 4 pi plus 6 pi k. Notice that those are not like terms because one of them has a k and one of them doesn't. And then 3 on bottom here is like 3 over 1, which means we flip up and multiply
Just like you learned how to do in, like, I guess 5th grade. Rowan hasn't learned it yet, so it's going to be a 5th grade deal, I guess. He's in 4th grade. So.
Or later, whichever.
Yeah,
So the numerator will be over 3 times 3, which is 9. Now that we have this, this is what we're going to plug 0, 1,
Right.
and 2 into.
And that's what becomes the inside part of our cosine.
Yeah. So if k is 0, then we have the third root of 3 times cosine. If we put in a 0 here,
4 pi over 9.
right, because this will go away, so we'll just have 4 pi over 9. And if you're having problems with that, actually write it out with 0 and then see what happens.
And look at it. And again, you should have 4 pi over 9 in both places for both trig functions. If you don't, then there's a whoops somewhere along the way that you're going to have to locate.
We only did this once because we know these have to be the same.
Yeah, they've got to be identical.
Okay, so k equals 1. We still have the cube root of 3. And now we need to think about if
So if I put 1 in there, I'm going to have 4 ply.
4 ply?
I got some floor ply. I got some floor ply saran wrap. You need 4 pi plus 6 pi, which is 10 pi over 9.
Did you say 4 ply saran wrap?
Yeah. Is it 4 ply Reynolds wrap?
Does saran wrap even have ply?
I don't know.
Okay, 10 pi over 9. That's not 10.
That's a pi.
That's a pi.
10 I like pi.
Pi over 9 plus I sine 10 pi over 9. All right, that's when k equals 1. Now we got to do k equals 2.
So now you're going to substitute in the 2 for the k, and that's going to be 6 times pi times 2, which is 12. So 4 pi plus 12 pi.
That's a tough one. Do you think
16 pi, I think.
times
Yeah,
6,
it's
12,
12, 16.
12 and
16?
16 pi.
Yeah, I like 16.
Okay. 16 pi over 9 plus I sine 16 pi.
This
over
is your cube root of the complex number, 3 cosine 4 pi over 3 plus I sine 4 pi over 3. Now, do you want to know how you can check yourself real quick? There's a real quick, easy check to see if you've kind of gone the right direction.
Okay.
Well, check it out. We started with 4 pi over 9, right? Mm-hmm. Then we got to 10 pi over 9, right? And then we got to 16 pi over 9, right?
You know, I noticed that those are 6 pi over 9 apart.
If you do your math correctly
That should happen.
between 0 and 1,
Yeah.
then you know what to add every single time.
Yeah,
And
it's
you know
a
what
pattern.
You know what happens if we add 6 pi over 9 to 16 pi over 9?
We get 22 pi over 9,
Which
is 4 pi over 9.
there
if
you go.
Subtract 2
That's
pi.
correct. And so now we're back to where we started.
Amazing.
Amazing indeed.
Okay.